Okay, this is just a quick lesson in how to name things. We call that nomenclature in chemistry. Okay, if you want to accurately name a chemical compound, you have to have a periodic table with you. There's really no way around that. And part of that is because first thing you need to do is see if you have an ionic compound. An ionic compound consists of a cation, that which forms as an element that forms a positive charge, and that tends to be metals that form that. So metals are in this loop here. There is a stair step on the periodic table that goes like this. So really anything to the left of this stair step is considered a metal. So this circle is supposed to really go more like this if you want metals. Okay, so those are again things that form a positive charge, metals. We have to distinguish those from anions, things that form a negative charge, and those are nonmetals. Nonmetals are here on the periodic table, so that's anything to the right of that stair step that I drew. So these form a negative charge. So that's important. That's one of the reasons you have to locate your element on the periodic table as one of the first things that you do if you want to name it. Okay, chemical compounds fall into different categories according to what they contain. So let's start with something called a type 1 compound. These compounds are binary. That means they have two elements in them. And they're ionic. And ionic means they have both a positive thing and a negative thing. And remember we said positive things are usually metals. So positive things are metals and negative things are nonmetals. Now, type 1 compounds, the metal is a bit more specific than just saying, here's my stair step and then anything to the left of the stair step. It's a little bit more specific with type 1. So type 1 compounds, where is your metal going to be? It's either going to be here, so this is your one area that it could be. This could be your alkali metals and your alkaline earth metals, or it could be silver, zinc, or aluminum. So I've put little circles, these three things right there. And those are going to be your cation. Those are type 1 because they are dependable. You know exactly what charge they form. If it's in this column on the periodic table, it's forming a +1 charge. Here it's forming a +2 charge. And these guys, just count 1, 2, 3. It's going to be silver +1, zinc +2, +2, that should read, and aluminum +3. So since these guys are known and you can depend on their charge, they're the easiest things to name. Okay, so let's get on to how do you name those. First off, we start with the cation. That's again the metal, and the name stays the same, so no change there. The anion, that's going to be the nonmetal, and remember that's found over here. The ending changes to "ide." So maybe you've got a metal like magnesium. I'll put a little circle around that. And it's getting together with a nonmetal like chlorine. The name's going to be pretty simple. It's going to be magnesium chlor, not chlorine, but magnesium chloride. Okay, well, we know how to name something that has a metal and a nonmetal that are in those groups, but how do you write that formula in the first place? We said it was MgCl2 for the formula. What we do is we use the periodic table to determine the charge. So you can see on this periodic table I've added some charges. We've got the 1+, 2+, 3+, and that refers to the charge of that whole column, at least here down to the stair step. So anything sort of like up from the stair step. So boron will be a 3, nitrogen, phosphorus, arsenic, 3-, oxygen, sulfur, selenium, tellurium, 2-, and then 1- down this column. Noble gases really don't form a charge, so we won't see those. Okay, so here what we do is we apply the charge. Charge goes to 0 in the compound. So Here's my example over here. I have magnesium 2 plus. I know it's 2 plus because it's in the second column. Nitrogen 3 minus. I know it's 3 minus because it's in this column here. And in order for the entire compound to have a 0 charge, I'm going to need 3 magnesiums. So that would be, if you follow over here, it would be magnesium, remember, has a 2 plus charge, and I'm going to need 3 of those. And if I had the nitrogen with the 3 minus charge, I'm going to need 2 of those, because look what happens if I multiply these, and I kind of have a line down the middle. I multiply the 2 plus and the 3, that's going to give me 6 plus. I'm going to multiply the 3 times the 2, that's going to give me minus 6, and those are going to add to 0. Now another way that people just say to do this is you can flip-flop the charges, drop them down, and then you do have to remember to reduce if necessary. In this case, it's not necessary. So what that looks like, I'm going to do it down here, is you just Mg 2 plus and 3 minus charges get flip-flopped and dropped. So my resulting compound is Mg3 and 2. Now the reason why we say reduce is that sometimes those numbers are not going to be in the lowest possible ratio. So let's take an example of that. Let's say magnesium was getting together not with nitrogen this time, but with oxygen. So I'm going to do that down over here. So we have magnesium, and we have that, give that a 2 plus charge. Oxygen, we give that a 2 minus charge. We flip-flop and drop the charges. Well, we're not going to write it as Mg2O2. Okay, so then if you see these charges, they're already at 0, aren't they? So we are just going to write that it's like you divide it, reduce it, by dividing each of those elements by 2. So you have MgO as your formula. This would be called magnesium oxide, and this would be called magnesium nitride, right? So these are type 1 binary ionic compounds. Okay, in type 2 binary ionic, same thing as type 1. The only thing is, it's all the metals that we didn't just talk about. So anything in the yellow column, these are called transition metals. Those are going to be involved. The pink column, this is like, or the pink columns, I should say, other metals. And then we don't have to worry about, remember these 3 right here? We don't have to worry about those because those are type 1, those are known, we're good on those. So here, since these charges are unpredictable, we use a Roman numeral to indicate, and we'll talk about that in the next slide. Okay, so the cation in this case, again, it's one of those transition or other metals, and the suffix of the nonmetal changes to "ide." So for example, iron, we don't know its charge, it's different every time, so we have to say it's iron 2 oxide, and that would mean that iron has a 2 plus charge. So I want you to know that this Roman numeral here refers to that 2 plus charge. Okay, so how do we write the formula from the name? We use that Roman numeral in the name in the periodic table to determine the charge. So what we do here is we flip-flop and drop. We reduce just as normal. The only thing is, instead of the column on the periodic table telling us the charge, it's going to be the Roman numeral that tells us the charge. So here we have my iron with a 2 plus, my oxygen with a 2 minus. Remember to reduce, and it's FeO. Okay, another thing is, though, I can work backwards from the formula on these, and I can get the charge. Let's take an example of that. So let's say I have manganese, and it's called, well, let me put the formula. It's Mn2O3. So from this, remember we flip-flopped and dropped? So if you want the name, you can kind of unflip. That 3 is going to come up here. That 2 is going to come up there. And then I'm going to say that this would have been 3 plus. This would have been a 2, excuse me, that's a minus. 2 minus. So this is going to be called manganese 3 oxide. Okay, let's go on to 3. These are called binary non-ionic compounds. So here we have a nonmetal and a nonmetal. So it's going to be one from this side of the table bonding with another one from that group. And let's see in the next slide how to name them and then how to determine the formula from the name. So for these we use a Greek prefix. The only exception here is that you do not use the prefix mono for this first element. So you have a list of Greek prefixes that we've copied down in class: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So those are ones that you need to know. And the only thing to remember here is that there is no use of mono before the first element. So if I had carbon dioxide, and I think we all are pretty familiar with that compound, CO2, there is only one carbon, but we're not going to include that in the name. So the di refers to the two. Notice this is two nonmetals, a carbon and an oxygen. We need that periodic table there to determine they're both from that side. They're both nonmetals. If we had CO, which is carbon monoxide, we would use the mono because the mono is referring to the oxygen in that case, but you wouldn't say monocarbon monoxide. So again, never before the first element. Okay, so writing the formula from their name, you just need to know those Greek prefixes, and the prefix is going to modify whatever element it's in front of. So I have carbon. Since it says no Greek prefix, we assume that means one. And then we have dioxide, that means two oxygens. This doesn't exist, but if it was carbon trioxide, then you would have CO3. Again, that doesn't exist, but just for the uses of an example. Okay, when we get a little bit bigger in terms of number of elements in a compound, for right now, though, you're going to see that those actually are going to fall into one type. This is not always the case, but if you count that there are more than two elements present, for right now, you can count on the fact that these have an anion, which can be a metal, or this ion called ammonium. So if you look on the chart, it's right there. And the cation could be a nonmetal or a polyatomic. So you can see all the rest of the list is negative. So these are going to have more than two things in them. They're not binary. They have many atoms. So how do we name these? You've got to use your memory. There's 7 that I ask you to memorize, or this chart right here. So we write the formula from their name, same as before, flip, flop, and drop, but you're not going to find these elements on the periodic table because they are groups of elements called polyatomic ions. They are not single elements. So magnesium, we recognize that that is just a single cation in that case, so go ahead and use the periodic table, forms a +2 charge. We see the word nitrate, that indicates not nitrogen, that would be called magnesium nitride. This 8 is one of the ones you need to know. So if you look over here, nitrate is there, and we would memorize that that has an NO3 and then -1 charge. So if I crisscross my charges, flip, flop, and drop, that 2 comes down here. Because you have 2 of those groups, it would look very weird if you just put NO3, 2. It would look like NO32 oxygens. So we do use parentheses around that to indicate that there are multiple groups of the NO3. Okay, the last thing we'll name are organic compounds. These are compounds that contain carbon and hydrogen, and right now we're only naming the simplest type. So here the suffix is going to be ane, A-N-E, and the prefix, it depends on the number of carbons you have. So if it has 1 carbon, you call that methane, 2 carbons, ethane, 3 propane, butane, pentane, hexane, heptane, octane, nonane, decane. So what we need to do here is you do need to memorize the prefix, and that indicates the number of carbons. So a helpful formula that we can use to write the formula from the name in this case is that C, which subscript there N means the number of carbons. So let's take an example. If C were 3, then how many H's would you have? N stands for this 3, so N is the number of carbons. So my H's would be 2 times 3 plus 2. So double it and add 2. So my formula here would be C3H8. And again, my name depends on the number of carbons. So this is going to be propane. So that concludes naming. If you have any extra questions on this or need more help, there's some great Khan Academy videos out there. And you can also do some problems in the back of the chapter that are in blue and check those answers in the back of your book. Good luck!